far, we've already learned about linear functions as well as quadratic functions. Today, let's open our minds to the concept of exponential functions and see what they're all about. So let's take a minute to just recap. As we see here, we have a linear function. A linear function always has a constant rate of change and will always be graphed as a straight line. Our constant rate of change is called our slope. In this graph, we have a slope of 2/1, meaning every time we plot a new point, we will go up 2 and to the right 1. The equation of a linear function will always look like f of x equals mx plus b, where we have our slope, our rate of change, and our y-intercept. We've also learned about quadratic functions. These graphs are in the shape of a parabola, which can be an upward u or a downward u. A quadratic function's equation looks like f of x equals ax squared plus bx plus c. The important part of a quadratic function is the exponent of 2, showing us that a parabola can have 2 x-intercepts. Now on to our new topic, exponential functions. As you see, the standard form of an exponential function is f of x equals a times b to the exponent of x. The a in the equation stands for our initial value. The b in the equation stands for the change factor. And finally, the x, which is our exponent in this equation, is our independent variable. Now I'm going to show you an example of how and why we would use this. Alright, so the example we're going to use today is going to be based off the coronavirus, because why not? However, all the numbers that I give you in this video are not actual, they are not backed up by any references. I am just making them up off the top of my head. So, with that, let's say initially there was 282 people affected by COVID-19, the coronavirus. Then every day that goes by, the percent of people infected by coronavirus increases 40% each day. And finally, x is the number of days that have gone by since the initial 282 people were affected. So here would be the equation for the given information. We have our initial value of 282 people affected. We have that being multiplied by 1.4 because it is increasing by 40% each day. And our exponent is still x because we need to now calculate how many days have gone by. Okay, so now I'm going to show you how we can evaluate this function, just like we would with any other function and function notation. If I wanted to evaluate how many people were affected by the coronavirus after one day, I would replace f of x with f of 1 and put 282 times 1.4 to the first power. If I wanted to find out how many were there after 2 days, I would put f of 2 equals 282 times 1.4 to the second power. I would then do the same exact thing with days 3 and days 4. Notice all I am doing is changing the exponent, which is our independent variable. I then use my trusty calculator to figure all of that out. Here are the answers I got. I'm now going to write them on the board. If you notice with an exponential function, these numbers are growing very big, very fast. As we know that people with coronavirus are more and more getting affected each day. Over here, I am going to write those numbers, but I'm going to round them. So after one day, there was approximately 395 people with the coronavirus. Day 2, about 553. Day 3, approximately 774, and after day 4, around 1,083 people. So now I'm going to show you what this looks like when it's graphed. As you can see here, I created the graph for my exponential function. On our x-axis, we have the number of days, 1, 2, 3, and 4. And on our y-axis, we have our number of people affected. I did have to skip by 100 so that I would be able to fit all 4 points. Okay, so let's graph this together. So originally, remember, the initial value was there was originally 282 people. So on my y-axis, I'm going to put 0 to 82 because that's going to show me my y-intercept, my initial value. So that's where it started. After 1 day, we had about 395 people. After 2 days, we had about 553 people affected. After 3 days, we shot up to 774. And on the 4th day, we shot all the way up to 1,883. Okay, so if I was to connect these, notice that it is not going in a straight line. It is on a curve. Okay, this is because these are not moving at constant rates. There is no slope in this problem, so it is not going to graph a straight line. However, it's also not going to graph a parabola because our exponent is not always 2. It is constantly changing because our independent variables, these were our exponents. So as we see, an exponential makes a curve-like shape.
Okay, so let's look at this new function, y equals 20 times 0.7 to the power of x. So the question asks, what type of function is this? Automatically, we are going to know that this is an exponential function because there is an exponent of x. Okay, so right here, this exponent of x is always going to give away the fact that our function is exponential. Now what we're going to do is we are going to build a table of values. So really what that means is we're just going to evaluate, just like we did before. We're going to take our x values and we're going to plug them in to our function y equals 20 times 0.7 to the power of x. So let's do that down here. So what I'm going to do is I'm going to find 0 first. I'm going to do 20 times 0.7 to the 0 power. That just equals 20. Then I'm going to do 20 times 0.7 to the first power. That equals 14. Now I'm not doing this in my head. I do have a calculator, which I do insist everyone using. 20 times 0.7 to the second power is 9.8. 20 times 0.7 to the third power is 6.86. Okay, so if you noticed, I finished putting in the x values of 4, 5, 6, and 7. Every time the number got smaller and the decimal got larger. So overall, this entire exponential function is decreasing. So now what we're going to do is we are going to graph this. Okay, and on my graph, as you can see, I already labeled my x and my y axis. On my x axis, I have, I'm going by 1s. However, on my y axis, I am going by 2s. That way I can fit all my points. Okay, so now we're going to start graphing. Our first point is going to be on 0, 20. Our next point is going to be on 1, 14. 2, 9.8. Okay, so those are some ugly points, but they are the points. As you notice, we are decreasing. Again, it is not in a straight line. If I was to try to connect these in a straight line, you see that that does not work. So I am going to connect these with a downward curve. And again, not the best, but as you see, it is not a straight line. It is not a parabola. It is not going to come back up this way because it is just going to continue to decrease. So there you go. So what we've learned today is we've learned that exponential functions have exponents of x, and that when we are evaluating, we evaluate them just like we would in any other function. We replace our exponent, which was x, with our x variables. And when graphing, we graph our points. I hope you learned a lot today.